In the previous video, we reviewed some of Swift's important operators and types. In this video, we're going to look at Swift's main collection types, which include arrays, dictionaries, and sets. The most common collection type is the array type. An array is simply a list of items of the same type. We're all familiar with the following array definition syntax, and we can define the same array in multiple ways. When using arrays, we get access to familiar operations that are available in other programming languages. For example, the isEmpty property is used to check whether the array is nil, and the count property is used to return the number of objects in the array. To access the first or last elements of an array, we can simply use the first and last properties, which will naturally return nil if the array is empty. We can also access an element in an array directly through subscripting, which of course can lead to runtime crashes if we fail to validate whether our index is within bounds. Since we have declared the array as a variable, we can easily append a value or a set of values using the append methods, append and append contents of. We can also insert a value at a given index using insert. This may all be common knowledge, but what's less obvious is that arrays in Swift have value semantics. In other words, their values are never shared. So when we create a new variable and assign an existing array to it, a copy is made. For example, in the following code snippet, A is never modified. This is because B is a copy of A, not a reference to A. Those coming from Objective-C are probably used to seeing arrays defined in two ways: NSArray for an immutable array, and NSMutable array for an array with values that can change. In Swift, we can define an immutable array by simply using the keyword let, rather than using var, which of course gives us a mutable array. For more examples and additional notes on arrays, you can visit this video's resource page here. A set is a collection type that will only allow the storage of unordered, distinct, hashable values of the same type. When the need arises to create a collection of unique items, a set is the best choice. We can define a set, much like an array, with var representing a mutable set and let representing an immutable set. In this example, we're looping through an array of 10 names and inserting each name into our set. Even though we're attempting to insert 10 items, our set only contains 8. This is because, unlike array, our set will not allow any duplicates. Set has many of the same methods and properties as array, including isEmpty, first, insert, remove, and more. It also comes with some useful comparison operators, including exclusive OR, which compares the left and right sets and only returns non-matching elements. Intersect does the opposite, giving us only the matching elements from both sets. Subtract returns all of the elements from the left, but with the elements from the right removed. Union combines the left and right sets, returning all of the items from both the left and the right. All of the operations we just looked at also have in-place versions which, providing we're working with mutable objects, function the same as the non-in-place versions, but rather than returning a brand new version of the set, they simply update the set to the left of the dot in place. Again, for more examples and resources on set, you can visit this video's resource page. The last of the common collection types that we'll be looking at are dictionaries. A dictionary is an associative array that stores keys of the same type and values of the same type in an unordered collection. With each key-value pair, the key acts as the identifier for its adjacent value. This key-value relationship structure makes dictionaries particularly efficient at storing and fetching values, which is most likely why we see dictionaries so widely used throughout the Cocoa framework for persistence. One such example is NSUserDefaults. We can define a dictionary like this. Notice that this dictionary is defined with a key of type integer and a value of type string. We can initialize the dictionary with values or assign values to it later via subscripting. Over here, notice that I've associated key 145 with John and 146 with Jane. If we want to access one of those values, we can easily do so through subscripting. We can also update values without the use of subscripting by using .updateValue. To remove a value, we can simply use .removeValue for key. There are also approaches to extracting values from entire dictionary datasets. For example, we can loop over a dictionary using a tuple, where the declaration on the left will represent the key with the variable on the right representing the value. We also have the option to extract a collection containing all of the keys or containing all of the values by using the .keys and .values properties. Obviously, I haven't covered everything here. If you'd like to learn more about collection type, I'll be maintaining some resources on this topic here. In this video, we've looked at some of Swift's collection types, arrays, dictionaries, and sets. In the next video, we'll review Swift structs, classes, and enums.